Hello and welcome to Algebra, where today we're going to learn how to add and subtract polynomials. All right, polynomials are just expressions that have variables and exponents and things like that. And we're going to learn how to add and subtract those today. All right, but one thing we need to know is standard form. All right, standard form. Our answers must always be written in standard form, which means we put the biggest exponent first and we go to the smallest exponent. So let me give you an example. If I'm looking at this one, this 3x minus 8 minus x squared is my biggest exponent, and there's a minus sign in front. Remember that sign in front stays with it. So if I was going to rewrite this in standard form, I would write negative x squared. All right, what's my next biggest exponent? Well, I have 3x, which is really an exponent of 1, but we put all of our variables first and then our constants at the end. So that's a positive 3x, so I'm going to write a plus 3x. And then the constants, which are just numbers, we're going to put at the end. So this is a minus 8 or a negative 8, so then I would write minus 8. So this is in standard form. Go ahead, pause the video and try this one on your own. See if you can write this one in standard form. All right, hopefully you paused the video and wrote this in standard form, but here it is, x squared plus 3x minus 5. So we're putting all of our variable terms first, and then we'll put the variable terms in order from the biggest exponent to the smallest exponent, and then our constants, our just numbers, go at the end. All right, so let's see here. When we're adding or subtracting polynomials, all we're really doing is combining like terms. So remember, if you think back to when we learned combining like terms, we can only combine things that have the same variable and raised to the same power, right? And we add and subtract the coefficients. Variable and the variable power, our exponent, stay the same. All right, so when we add or subtract polynomials, it's just like combining like terms. We add or subtract the coefficients, the variable and the exponent stay the same. All right, and remember, it's always important to write our answer in standard form. So they had an example here. They had 2x squared minus 3x plus 4 plus x squared plus x minus 5. So what could they combine? Well, they can combine anything with x and squared, right? So this 2x squared can be combined with this x squared. So 2x squared plus 1 more x squared will give me 3x squared. I can't combine it with this x because it doesn't have a squared, right? It has to have the same variable and the same power. All right, so negative 3x I can combine with this plus x. Negative 3x plus, really, this is 1, right? Negative 3 plus 1 would give me negative 2x. All right, and then I also have this plus 4 and this minus 5. I can combine those because those are just constants, they're just numbers, right? 4 minus 5 gives me negative 1, so there's our answer right there. All right, so it's just like combining like terms. Remember, you have to have the same variable raised to the same power or exponent. All right, let's try a couple addition problems. All right, so this first one here. So I see I have an x squared. Do I have any other x squareds? I do not. So I'm just going to rewrite x squared over here. I can't combine anything else because there's no other squares, right? All right, but I see I have a plus 5x and a minus x, right? I can combine those because they're both just x's. 5x minus, really, this is a 1. 5 minus 1 will give me 4x. And it's a positive 4x, so I put a plus. So it'll be plus 4x. And then this plus 6, there's nothing to combine it with, so I just bring it down. And that's my answer, x squared plus 4x plus 6. All right, let's do the one below it. So let's see here, I got 2x squared. Do I have any other x squareds? That's an x, but no square, nothing there. Oop, I see one here. I got a plus 5x squared. So 2x squared plus 5x squared will give me 7x squared. And I combine those, they're no longer there, and they're now 7x squared. All right, let's see, what else I got? I got a minus x. Do I have any others that are just x? I do, I got a plus 3x. I can combine those two, right? Minus 1x plus 3x would give me a positive 2x. So I'm going to put plus 2x. And I combine those two. Those are gone. All right, now I'm left with 3 and minus 7. I can combine those, right? Those are just numbers. 3 minus 7 gives me negative 4, so I write minus 4. There we go, and it's already in standard form because I started with my x squared first, my biggest variable first, and went down. All right, go ahead, pause the video, see if you can try these two. Remember, you want it in standard form, so I would start with your x squareds, see what you can combine, then start with your x's, and then start with your constants. All right? Pause the video and give it a shot. All right, hopefully you paused the video and did these two on your own. There's your worksheet, or there's my answer so you can check your work. All right, so important facts to remember with distributive property. When distributing, distribute all terms inside the parentheses. Pay attention. Sometimes you might be distributing a negative. When multiplying, we when multiplying, we multiply the coefficients and we add the exponents, right? X times x would be x squared, right? Where x plus x would be 2x. Because remember, there's a 1 in front of these, right? We're adding them together. 1 plus 1 is 2. Right? X to the second power raised to the third power. Remember, we multiply those two. 2 times 3 would give me x to the sixth power. Okay? Then we would combine our like terms and write our answers in standard form. Always in standard form. Okay? All right, so let's try one. All right, so I have this, and I see it says minus this. So I have to get rid of these parentheses. And the way I do that is I distribute, right? So this minus parentheses really means there's a negative 1 there. Remember, there's an invisible 1 in front. So really this is negative 1, and I got to distribute it to everything on the inside over here. So negative 1 times negative 5 would give me 5x squared. Negative 1 times a positive x would give me a negative x. Negative 1 times a positive 8 would give me a negative 8. All right, to get rid of these parentheses, what I'm really doing is taking this 1, it's a positive 1 because there's no negative, and distributing here. But when you times everything by a positive 1, it stays the same, right? So it'd be 9x squared, it's all the same. 9x squared plus 2x minus 1. And then this was a positive 5x, so I put a plus. Boop. All right, so then what I do is I combine my like terms, right? So I want to start with my x squareds because those are my biggest exponents. So I can start with that first. So I see 9x squared. And I see a 5x squared. I can add those two together because there's a plus right here. 9x squared plus 5x squared would give me 14x squared. All right, I combine those. I'm done with my x squareds. All right, I see I have a plus 2x, and I can combine that with a minus x. All right, so plus 2x minus x would give me a plus 1x. So I can just write plus x. And then I have a negative 1 and a negative 8. Negative 1 minus 8 would give me negative 9. And there's my answer. I can't do anything else, and it's in standard form. All right, let's do one more together. All right, so I need to get rid of these parentheses, so I need to take this negative 1 and distribute it to everything on the inside. So negative 1 times 2x to the third power would be negative 2x to the third power. Negative 1 times a negative 3x to the second power would be a positive 3x to the second power. Negative 1 times a positive 3 would give me a negative 3. All right, and on this one, remember it's really a positive 1 I'm distributing, right? But there's nothing really to distribute because anything times 1 is itself. So I'm just going to bring everything else down. There we go. All right, so now I can combine my like terms, right? So I got 3x to the third. That's my biggest exponent, is to the third power. So I'm going to do that first. So I have 3x to the third, and I see I have a negative 2x to the third. So 3 minus 2 would give me 1. So it'd be 1x to the third, or just x to the third. All right, I'm done with those. All right, so now I see I have an x squared. So let's do that one, x squared. Negative 4x squared, and I see I have a plus 3x squared. Negative 4 plus 3 would be negative 1. So I can just write negative x squared. And I combine those. All right, what's left? I have negative 4, and I get a negative 3. If I combine negative 4 with negative 3, I get negative 7. And there's my answer. All right, so when you're subtracting, you have to distribute that negative 1 to everything on the inside, and then all you're doing is combining your like terms. All right, let's do one more thing down here together. This is called modeling by picture, okay? So it says the white boxes, the white squares are x squared, and it says the rectangles, these gray rectangles are negative x. If it's a white rectangle, it is a positive x. If it's a little white square, it's a positive 1. If it's a little gray square, it's negative 1. All right, so I'm going to rewrite this into math. So I have 3 big squares, white squares. So that is x squared, right? So this would be 3x squared, right? Because I have 3 x squares. All right? So now I see I have 2 shaded in rectangles. Shaded in rectangles with negative x. So that would be negative 2x, because I have 2 of them. And that said it means negative x, so negative 2x. And now I see I have 1, 2, 3, 4 little x's that are shaded in, or little squares that are shaded in, and those are negative 1. So negative 1 times 1, 2, 3, 4 would be negative 4. And that's how we see these pictures, all right? Go ahead, pause the video, try this one on your own, see if you can do it. All right, hopefully you paused the video and you got this. I had 3 negative big x's, I had 2 positive x's, and I had 4 negative ones, right? So that is how we look at these pictures. Sometimes they'll show these pictures and say add and subtract these two things. And that's what we're going to do down here. All right, so all you're going to do, try this on your own. All you're going to do is write what the picture means, and then you're going to add or subtract it based on what it's telling you. All right? So basically, when you're adding and subtracting polynomials, all you're doing is you're combining like terms. And you're combining like terms, it means you have to have the same variable raised to the same power. And then when you're done, you remember it has to be in standard form. So your biggest exponent goes first, and then it goes down to your constants. Right? All your variable terms go first, constants always go at the end, or numbers by themselves with no variables always go at the end, right? And that is standard form. All right, if you ever have any questions, please ask a teacher, and I'll catch you next time. Bye!